In this presentation, we will learn how to insert a node at certain position of a singly linked list. So let's get started. Here is an assumption I'm making over here, that is position where the new node needs to be inserted is given to us. Okay, let's say the position is 3 where we want to insert our node. This is the linked list we are available with already. Here you can see this head pointer is pointing to the first node of this list, and I want to insert a new node at this position number 3, that is at this particular position between these two nodes. This represents position 1, this is position 2, and position 3 means between these two nodes. For this purpose, the first step is to create a new node. Obviously, we need to create a new node, and then after that, step 2 is to traverse the list. For this purpose, I have created this pointer PTR, which will do our job of traversing the list. Here, we will move our pointer to the second position of this list, just before the position where we want to insert our new node. So pointer will move just one position forward. After this, step 3 is to update the links. We will then update the links, that is first we will update the link part of this node by using this line of code, that is ptr2link equal to ptr_link. We want to store this particular address in the link part of this node because we want this node to point to this particular node. That is why ptr_link will help us to get this address, and by using ptr2link we can access the link part of this node. So here ptr2link must contain ptr_link, that is this particular address. So here we can update the link part of this node very easily. After this, the next step is to update the link part of this node by the address of this node, right? So here we need this particular line of code, that is ptr_link equal to ptr2. We know that ptr2 contains this address 4000. We just need to update the link part of this node by this address, that is 4000. And let me tell you, the order is very important. First, we have to update the link part of this node, and then we can update the link part of this node. Why is that so? Because if we update the link part of this node first, then there is no way we can access this node. We have to access the address of this node. That is why it is important to update the link part of this node first. If we update the link part of this node first, then it will get updated by the address 4000, and we won't be able to access this node address at all. That is why it is important to update the link part of this node first and then the link part of this node. Now let's see the program which helps us in adding the node at certain position, the position of our choice. Here you can see this is main function, and in this main function we have this piece of code which helps us in creating a linked list. Here the head pointer is pointing to this node, and we have these 3 nodes in our linked list initially. For this purpose, I have used these add@end functions. I'm assuming here that we are already available with these functions, and we know that what these functions will do. These functions will add the node at the end of the list. If you have no idea about how to add the node at the end of the linked list, then please see my previous lectures on adding the data at the end of the list. So after the creation of this list, we will create 2 variables, data and position. This data variable represents the data of the new node we want to insert, and position represents the position where we want to insert our new node. And this is how they look like. Data and position. Data contains this value 67 and position contains this value 3. After this, we will call add@pos function where we pass head, data and position. And you can see over here, this is add@pos function which will receive those parameters, and of course due to which we have our linked list, the data as well as position. Now here you can see I have created this pointer PTR which will point to this particular node, that is the first node of this linked list. After this, we have this PTR2. This piece of code is helping us in creating a new node of this list, and you can see over here this is the new node created, and I'm assuming that the address of this node is 4000 and PTR2 is a pointer which is pointing to this node. You can see over here that PTR2 data contains this data, that is 67, and currently ptr_link is equal to null, that is the link part of this node is null. After this piece of code will help us in traversing the list. For this purpose, I'm using this pos variable. Of course, we need a while loop because we want to traverse our list. And for this purpose, first we will decrement the value of pos, that is, we will decrement it by 1. And then after that, we will check this condition, is pos is equal to 1? No, it is not. Right now it is 2. Therefore, we will get inside this while loop. We will update the PTR by ptr_link, that is by this address 2000. This means that it is now pointing to this particular node. After this, we will decrement the pos by 1 again. Here now it becomes 1, and then we will again check this condition. Is this satisfied? No, because right now this is 1 and 1 not equal to 1 is false, right? So we'll get outside of this while loop. Please note that the traversal is based on post variable. Here we need to decrement the post first, and then after that we have to check this condition, is post not equal to 1. Instead of this condition, you can also check is post not equal to 2, then this step is not required. Okay, this is the logic created by me. So you can use your own logic as well. Here you can check post not equal to 2. That is also correct. Ultimately, we want our pointer to move just one position forward because we want to insert our node between these two nodes, right? That is why it is important to move our pointer one position forward. Logic doesn't matter. I have used this logic. You can use another logic as well. After this, of course, we will update the link part of this node by the address 3000. And this can be updated by using this line of code which we have already seen. And then after that, we will update the link part of this node by the address 4000. This means our node is added between these two nodes. And then after that, you can see the linked list so created. Here, this node is added between these two nodes. After this, we'll get back to the main function. And here in this main function, you can see I have created PTR. That is the pointer which will point to the first node of this list. I want to traverse this list for printing all the elements of this list. That is why I'm using this pointer for traversal. Here you can see this while loop will help us in traversing the whole list, and it is helping us to print all the elements on the screen. You can see this PTR pointer will traverse the whole list, and therefore the output of this program is 45, 98, 67 and 3. So this program is helping us in adding the data at certain position. Okay friends, this is it for now. Thank you for watching this presentation.